Okay, so today I want to show you a program called Coiled. And Coiled is really a way to process data at scale. It allows data engineers to run functions in the cloud, but they don't have to worry about provisioning EC2 instances. They can simply give the API instance size name and let Coiled do the rest. And they don't have to worry about provisioning software or credentials or anything like that. So it's a really nice way to really process data at scale. It's really efficient. And what we're going to do in this example today is take a look at calculating pi. So I have two scripts here, and this first script is we're going to calculate pi locally and take a look at that code. So if we see what this does, first we're going to use the random library, which is built into Python, to generate random numbers. And we're going to do 100 million times. We're going to generate and evaluate 100 million random data points, X and Y values. So we initialize a couple of counters for the number of points that fall inside of a circle, and then initialize a counter for the total number of points generated. So we loop on a range, and we iterate n times, which was 100 million. And the underscore for the loop is just a placeholder because we're not using a variable here. But we're going to generate random coordinates, generate a random number between 0 and 1, and that's the x coordinate, and then same thing for y, and then we plot that. And we say if x squared plus y squared is less than or equal to 1, then it falls, the plot falls within the circle. And so the condition checks if the sum of the squared coordinates is less than or equal to 1, which is the radius of the circle squared. So if you think of area of a circle equals pi r squared, that's where that's coming from. So, and then you increment the counters based on what you get, if the point is within or the circle or not. But that a equals pi r squared is basically how you estimate pi, 4 times the inside circle divided by the total number of points. So that's what we'll run. We run that locally, and we can see there that it's running, and it just finished. And let's see what we got. So we got 3.14147884. So we got 8 significant digits. That ran pretty quickly. So now we're going to do the same thing with the other Python script, which imports the Coiled library. And the key difference, it's basically the same code, but we are going to map these jobs out in a distributed manner on a cluster that we're about to build. So we've got a function, we initialize a counter, we have a range, and then we generate those random numbers and multiply to see if it's less than 1, increment the total, and return the total divided by n times 4. So it's basically the same thing, just written a little bit differently. So using the coiled function this time. So when we run this, first thing it's going to do is create a cluster for us to run on. So, because we don't have one created yet. So as soon as we invoke it, we'll see a little bit of Python activity on the local machine, but the majority of the calculation is going to take place, actually all of the calculation of pi is going to take place in our cluster once it is built. So let's go ahead and execute this command. It's going to be Python 3 estimate underscore pi underscore coiled.py, and we're going to see what this does. So Python 3 estimate pi coiled.py, and the first thing it's going to do, if we hop over to the htop and see what it's doing, we can see there's very little Python activity in this case. It's basically just spawning the cluster creation. So we're creating a cluster called function-745, just a random number there. But if we go to this dashboard, we can see the cluster is starting to scale up. We don't have any workers yet. We don't have any uptime yet, but they're approximating the cost at 10 cents an hour. And below the running cluster there, you can see all my stopped clusters from previous jobs that I've run. So we don't have any metrics or barely have any logs yet, but you can see we started the cluster. Dask is pending. So Dask is basically distributed pandas. It's indexed pandas, I should say. We'll take a look at Dask here in just a minute. But if we go to the EC2 console, we have one machine. We're going to get 18 in total, but we've got one for now. And if we really wanted to connect to it using Instance Connect, we could, but we don't really need to. So as we wait for this cluster to come up, like I said, we'll have a total of 18 of these machines where we're going to calculate pi with more significant digits than what we did locally. So the idea is distribute the workload in the cloud, create the cluster, distribute the workload, calculate pi, and then shut it all down. So these are very short-lived, larger instances. These aren't particularly large instances, but they're larger than, you can have very large instances in your cluster if you'd like to have them. And they're short-lived, so they shouldn't be too expensive. So if we take a look at the infrastructure tab of our cluster, we can see that we have that one machine. It was queued, and then it started, and then the instance was running, and then it started downloading packages. So once it gets to the ready state, that's when it's going to start calculating pi, but we haven't gotten there yet. We're still in downloading. And we would see error if we terminated. We could go to the console and terminate any of these 18 machines, and it would go to an error state. But the job would continue. You would just lose one node, which makes the other nodes work a little bit harder to get the answers. So think of Hadoop, think of MapReduce and calculating pi in that platform. This is sort of a different way of doing it without having to keep a Hadoop cluster running all the time and having it be idle. So again, we just go to the EC2 dashboard here. We've just got the one instance, but it is starting to scale up, so we should have more instances by now. If we go back to the cluster, we can see over here on the infrastructure tab, we have a bunch more machines being queued, and they're also starting. So as you move from left to right, your queued values go down and your starting values go up. And then from left to right here, your starting values go down, your instance running goes up. And you go from instance running to downloading and downloading to ready. So once all 18 are ready, then all 18 of your machines are calculating pi. But that first one is ready. So we should see it actually calculating at this point. So that's where that Dask dashboard comes in, because we're using Dask behind the scenes here. So this is the task stream showing that we basically have one machine working because it was the first one that came up. And we've got a little less than 1,000 that are still queued, but soon we're going to see a bunch of tasks come in here. And there's the second machine right there, and the third, and the fourth, and the fifth. And if we click on CPU, we can see the CPU usage for each of these 18 machines. So pretty soon we're going to see all the distributed tasks here and the CPU utilization nearly 100% for all of the machines as it calculates pi. And we can keep a look at the progress bar to see how long approximately this is going to take to finish. And you can see we actually have 20 instances in this case, not 18, but it for some reason decided that we were going to go up to 20. So we're just going to let this run and see what we get here in just a little bit. You can also see if we go back to the cluster on the information tab, this is the code that we submitted to this cluster, which is really nice if you have to look back at history. You can see what code you gave it. And the CloudWatch metrics are basically summed here or presented to you in this view. So we can sort of hover over it and we can see the first thing that happened was all that downloading of the data. And then there's your downloading right there, that sort of peak of the cluster disk activity. And then once that was done, then we began user space CPU processing. So that's what these metrics are showing. When we take a look at the logs, we can see that Dask is running and the cluster is ready and all of the workers started taking on jobs. While we're waiting on it to finish, we can go over to the billing tab to see how many credits we've used. So Coiled gives you 10,000 credits to use for free. The only thing you pay for is the EC2 instance usage in your account, in your AWS account. But this lets you keep an eye on your usage of those 10,000 free credits. And I've used hardly any of them, probably about 11 or so total. So I have plenty to use yet in this Coiled free tier. So there it finished, just like that. On the right-hand side, we see 3.14 and all those significant digits to the right. And the job is done, and the CPU utilization dropped for all those machines. And so now if we go back to the main dashboard, we can see that our cluster is still there, but it's going to get torn down automatically here in just a moment. We can see that cost us about 13 cents to do it. So not too bad. Not too bad for 20 instances. Calculating pi cost about 13 cents. So if we come back to the console and refresh the page, we should see these machines start to drop away. And by the way, this instance size is M6i large. So if we put that in the API name, we can see not a terribly large machine, but it has 8 gigs of RAM and 2 vCPUs. So, but I could have specified a different instance type there, a bigger and faster machine if I wanted to. So we refresh, now we've got 7 machines, we refresh, and now we've got 0. So if we go back to the Dask and reload the Dask dashboard, it's not going to load because the cluster's dead now. It's coming down. It says ready, but it's stopping. So if we click on and actually it's gone already, so it's gone down to the stop clusters. If I take a look at the logs, I can see that the cluster was stopped, everything was stopped, and it was basically terminated. So all those EC2 instances are now terminated. So this is a really good way to run distributed workloads like this. And like I said earlier, scale functions in the cloud. It could be, it does not have to be AWS, but I used AWS in this case. You can also do, you can work with Pandas, Parquet, NumPy, Xarray, XGBoost, PyTorch, Airflow. You just use the libraries that you want to use and use it at scale. You can even do CLI jobs if you want to, or work with Jupyter notebooks in this way. So it's a great, easy, efficient way to get started with data processing at scale. So I hope you enjoyed this video, and thanks for watching.